Imagine a computer program that can learn like a human brain. This concept might sound like science fiction, but it's becoming a reality thanks to the advancements in artificial intelligence. This is the exciting world of artificial intelligence, and at its heart are neural networks. These networks are designed to mimic the way our brains process information. Neural networks are powerful tools that allow computers to learn from data and make intelligent decisions. They can analyze vast amounts of information much faster than a human ever could. Just like our brains learn to recognize patterns and make connections, neural networks can be trained to identify objects, understand language, and even predict the future. This training involves feeding the network large datasets and adjusting its parameters. These networks are not magic, though they sometimes seem like it. They operate based on mathematical algorithms and principles. They are built on simple principles inspired by the structure of our own brains. Neurons in our brain communicate with each other through synapses, and neural networks use similar connections to process information. By understanding these basic building blocks, we can begin to grasp the incredible potential of artificial intelligence. This knowledge opens up a world of possibilities for innovation and problem solving. Let's dive in and explore the fascinating world of neural networks. From self-driving cars to advanced medical diagnostics, the applications are endless and ever-evolving. The basic building block of a neural network is called a neuron. Think of a neuron as a tiny messenger in your brain. It takes in information, processes it, and then sends a signal to other neurons. In a neural network, these neurons are simulated using mathematical functions that mimic the behavior of real neurons. Each neuron receives input signals from other neurons or from the data itself. These signals are then combined and modified by the neuron's internal weights. Weights are like the strength of connections between neurons, and they determine how much influence each input has on the neuron's output. Just like our brains have billions of interconnected neurons, neural networks are made up of layers of interconnected artificial neurons. These layers are organized in a hierarchical structure with information flowing from one layer to the next. The first layer receives the input data, such as an image or a piece of text. This information is then passed through the network, with each neuron processing and transforming the data before passing it on to the next layer. As the data flows through the network, the weights and connections between neurons are adjusted, allowing the network to learn and improve its performance. Learning from mistakes, training a neural network. So, how do neural networks actually learn? The process might seem complex, but it can be broken down into simpler steps. The learning process involves feeding the network a massive amount of data and adjusting the weights of the connections between neurons to minimize errors. This is done through a method called backpropagation, which helps the network learn from its mistakes. This process is called training. During training, the network continuously adjusts its parameters to improve its performance. Imagine teaching a dog a new trick. You give it commands and reward it when it responds correctly. You give the dog commands and reward it when it responds correctly. Over time, the dog learns to associate the command with the desired action. Over time, the dog learns to associate the command with the desired action. This is similar to how a neural network learns. Similarly, a neural network learns by adjusting its weights to produce outputs that match the desired outcomes. The network uses feedback to make these adjustments, gradually improving its accuracy. The more data the network is trained on, the more accurate and reliable it becomes. With each iteration, the network refines its understanding, leading to better performance and more precise results. A world of possibilities. Neural networks in action. Neural networks are already having a profound impact on our world, and their influence is only going to grow in the years to come. These complex systems, inspired by the human brain, are capable of learning and improving over time, making them incredibly powerful tools in various fields. From self-driving cars that navigate our streets with precision to advanced medical diagnosis systems that assist doctors in identifying diseases, neural networks are being used to solve some of the most challenging problems facing humanity. Their ability to process vast amounts of data quickly and accurately is revolutionizing these industries. For example, neural networks are used in image recognition software to identify objects and faces in photographs. This technology is not only used in social media platforms, but also in security systems and autonomous vehicles, enhancing safety and efficiency. They are also used in natural language processing to power chatbots, translate languages, and even write different kinds of creative text formats. These applications are making communication easier and more accessible, breaking down language barriers and providing instant assistance. As neural networks continue to evolve, we can expect even more groundbreaking applications to emerge, shaping the future of technology and transforming the way we live, work, and interact with the world around us. The potential for innovation is limitless, and the journey has only just begun.